Find a series for the square root of 1 plus x. Let f of x equals the square root of 1 plus x, which is the quantity 1 plus x to the power 1/2. We recognize that this is the binomial series with k equals 1/2. Note that the binomial series 1 plus x to the k is the sum of k choose n times x to the n. When n is 0, the first coefficient is 1/2 choose 0. When n equals 1, the second coefficient is 1/2 choose 1, and then 1/2 choose 2, and then 1/2 choose 3, and so on, with the factor x to the 0, x to the 1, x squared, x cubed, and so on. These coefficients can be evaluated using the formula k choose n, which is the product of k times k minus 1 all the way to k minus n plus 1 divided by n factorial. So 1/2 choose 2 is 1/2 times 1/2 minus 1 over 2 factorial, which is minus 1 over 4 over 2, negative 1 over 8. And 1/2 choose 3 is 1/2 times 1/2 minus 1 times 1/2 minus 2 over 3 factorial. Observe that we choose 3, so we end up with 3 factors in the numerator. The last factor in the numerator is k minus 1 less than n. Simplifying this, we have 1/2 times negative 1/2 times negative 3/2 divided by 6, which is 3 over 48 or 1 over 16. And so the square root of 1 plus x is 1 plus 1/2 x minus 1 over 8x squared plus 1 over 16 x cubed minus 5 over 128 x to the 4th plus ... We can use this series to come up with many more series. For example, if we replace x with negative x squared, then we end up with a new series. Simplifying this, we will end up with the square root of 1 minus x squared equals 1 minus 1/2 x squared minus 1 over 8 x to the 4th minus 1 over 16 x to the 6th plus ... We use this function, the square root of 1 over x, to obtain another series representation for another function. For example, if we replace x with negative 1 over x, then we end up with the square root of 1 minus 1 over x equals 1 minus 1 over 2x minus 1 over 8x squared plus 1 over 16x cubed, and so on. Note that we can use the first few terms to approximate the function. We can use the first few terms to approximate the radical function, as long as the absolute value of x is small. Or with the last series, as long as the absolute value of 1 over x is small.